Hello, esteemed judges. Allow me to introduce myself. My name is Mangde Anata Sindhu, a medical student from Warmadewa University, Indonesia. On this occasion, I will present my innovation entitled SIRIPLUS, a bioplastic wound paste based on cassava starch enriched with red betel leaf extract as an antibacterial agent. Modern wound care currently faces two major interrelated challenges. First, chronic wounds, especially diabetic foot ulcers, are highly susceptible to infection and often require repeated use of antibiotics, which contributes to the rise of antimicrobial resistance or AMR. Second, conventional wound plasters are generally made from non-biodegradable synthetic plastics, which increases the amount of medical plastic waste. Therefore, health and environmental problems occur simultaneously and require an integrated solution. Based on these issues, SIRIPLUS was developed with four main objectives. First, to develop a biodegradable wound plaster based on local biological resources. Second, to provide direct local antibacterial activity at the wound site. Third, to help reduce the excessive use of systemic antibiotics. And fourth, to minimize medical plastic waste in the long term. SIRIPLUS is a bioplastic wound plaster made from cassava starch as the main matrix and enriched with red betel leaf extract as a natural antibacterial agent. The novelty of SIRIPLUS lies in the combination of biodegradable materials and herbal antibacterial compounds in a single wound care product. Through this approach, SIRIPLUS not only focuses on wound healing, but also targets the reduction of AMR risk and medical plastic waste simultaneously. In addition, the use of local raw materials is a sustainable innovation with the potential for wide-scale development. Distinguished judges, I will now explain the layer design and working mechanism of SIRIPLUS. SIRIPLUS is designed with three main layers. The first layer is the backing layer, which serves as a protective barrier while allowing the exchange of oxygen and water vapor. This way, the wound remains protected but does not become excessively moist. The second layer is the active layer, which is a bioplastic matrix made from cassava starch enriched with red betel leaf extract as an antibacterial agent. The third layer is the skin contact layer, which is soft and maintains wound moisture to support the healing process. When the plaster comes into contact with wound exudate, the starch matrix will expand and gradually release the active compounds from red betel leaf, which function to inhibit bacterial growth and biofilm formation. Benefits and impact. SIRIPLUS provides benefits in various aspects for patients. The risk of wound infection can be reduced and the wound healing environment becomes more optimal. For the healthcare system, SIRIPLUS has the potential to reduce dependence on antibiotics and support AMR control strategies. Meanwhile, for the environment, SIRIPLUS is biodegradable, helping to reduce the accumulation of medical plastic waste, SDGs, and sustainability. So SIRIPLUS is also designed to align with the Sustainable Development Goals. This innovation supports SDG 3, good health and well-being, by helping to reduce the burden of wound infections through local antibacterial effects, thereby potentially reducing the use of systemic antibiotics. In addition, SIRIPLUS is also in line with SDG 12, responsible consumption and production, by replacing synthetic plastic-based bandages with bioplastics that can naturally decompose. The use of cassava starch and local herbal ingredients also supports a local resource-based economy and a more sustainable healthcare system. In conclusion, SIRIPLUS offers a sustainable alternative for wound dressings by combining medical innovation with environmental responsibility. This innovation is expected to become a new direction in environmentally friendly and sustainable wound care. Thank you for your attention, esteemed judges. Thank you.